So in the exam, this usually comes up, and when the first thing people do when they see this, they get really nervous and think it's incredibly difficult. Turns out this is just 2D Pythagoras that you done up twice. It's actually dead easy. So let's have a crack at this example I posted right here. So suppose you're given a cuboid with lengths 12, 15, and 7 across, so that's the dimensions. And they told us to find a diagonal length from this corner right across to this corner here, okay? So in the calculus length, you'll probably notice that it's actually, if you think about it, if you twist this cuboid around, if you think about it in a certain sense, we've actually got the line that cuts directly through its diagonal into two opposite end corners. Now, the simple way to calculate this is to consider that we have multiple lengths. So we're going to travel from here to here to here. So we consider traveling across. So let's look at lengths 12, 5, and 7. And the way Pythagoras works, we use the 3D method, which is simply a squared plus b squared plus c squared equals the diagonal d squared. So let's write this down. So this would be the general formula to work out its length, where d is the diagonal. So popping in all the values, we're going to have 12 squared plus 5 squared plus 7 squared equals d squared. So multiplying this out, you got 144 plus 25 plus 7 squared equals, in the calculator, 218. So d squared is 218. And what we do now is just square root it, and then you have root 218. And that's it, guys. That's literally it, how you find the length of diagonal on a cuboid. Seriously, it's this easy. You just literally sum up, find the square of each of these lengths, square root it, and boom, you got the perfect diagonal. Now let's look at another example. Let's look at square-based pyramids. So in this example, I'm going to give it a few lengths, okay, to give it some sort of angle. So we got, suppose we got this length. It's perfect square, so this is obviously 7. Let's get this a length of 7. And suppose we give this long diagonal a length of 9. Okay, the idea is that we want to find the length from, let's say we want to find the vertical height, basically from here all the way up to this one, right to the top of the tip of the pyramid. So the problem is, how do we get this length? I mean, we could technically force it across and make a right angle, but that's another piece of working out. Thankfully, freed by Pythagoras, we could actually travel to it. So think of this as some sort of a cuboid, yeah? So we've got another cuboid here, okay? If that's the sense, then we could actually use the technique that we can go across its base, through its width, and then its height. And there we go. Here is our 3D Pythagoras. And then at this stage, you know, we know this diagonal. In fact, we got diagonals right here. We know it's length 9. And now the question is, what is the length of these two sides? Well, because it's square and it's bang in the middle, we know that this is actually just 3.5. And this is also just 3.5. That's all. Now you literally use the 3D Pythagoras method, which is a squared plus b squared plus c squared, which we don't know, we'll call this size c, equals d squared, which is 9. So we got 3.5 squared plus 3.5 squared plus c squared equals 9 squared. That's it, guys. Smashing it. So let's solve this directly here. So putting this on the calculator and making c squared the subject, we should get 81. So 9 squared is 81. Take away these two squared, which is minus 12.25 minus another 12.25, all, yeah, and then we just simply square root both sides. Square root this, sum up square root, and we should get about 7.52 centimeters. And that's it, guys. Hope this helps, and if you need any questions or anything, just let me know.